Greetings, people of geometry. Here we are, part 2 of the review, picking up where we left off. This problem is asking for the length of the chord BD. Upon first glance at this problem, what do you notice? You notice that the diameter of this circle, radius of this circle, AC, must also equal AB. And AC is 10, so AB has to be 10. Right? Second thing I notice is that's a 90-degree angle. We had a theorem that said if a radius is perpendicular to a chord, it must bisect that chord. Therefore, I now have a triangle that's a 10-6 right triangle where the hypotenuse is 10. This is just a scaled up 3, 4, 5 triangle, meaning this has to be 8. If that's 8, the other side is 8. Or you use the Pythagorean theorem. Hopefully you recognize the 3, 4, 5 by now. But the problem asks for the length of BD, which is 2 times 8, and the answer should be 16. That's how you do that problem. Pretty simple. All right, here we have another chord problem. We know that the chord is 64. That's line segment AB over here. I have marked 64. The midpoint of the chord is 9 centimeters from the circle. So they're giving you that portion of the radius, which we know would have to equal whatever that is. That's not a very straight radius. Don't judge me. They want to know what is that radius, and they tell you right off the bat, hey, it is not 9. Well, just like the last problem, this perpendicular portion of the radius, marked there with that right angle, has to bisect that chord. Therefore, that's got to be 32, and that's got to be 32. Right? So now you have a triangle, a right triangle that's 9 and 32, and we're looking for the radius. Wow, that was not an R. Looking for the radius. Well, how do we do that? That's Pythagorean theorem. You know the legs. A squared plus B squared equals C squared. Bang. 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 How do I undo a square? I square root 1,105. For those of you that are addicted to calculators, it's about 33.24 centimeters. So again, that's incorporating Pythagorean theorem, understanding the radius construction of how it impacts a circle, and that perpendicular radius to a chord theorem. All right, moving on. All right, here we have a circle centered at the origin. Okay, and they tell you that the point -4, -2 is on the circle. It contains the point. So which of the following is closest to the length of the diameter? Well, right off the bat, I know I can just find the radius and multiply by 2 to get the diameter. So if I can find the radius and get half of one of these, I'm good to go. So how do I find that radius? Well, right off the bat, you have to see what? You have to see that that's going to be a triangle somehow. Well, how do I make that a triangle? Oh my goodness. Wow. See, it even happens here. You thought it just happened at the smartboard in person. No, it happens here. So that's my triangle. Well, what's my x coordinate? -4. So that's a distance of 4. Yes, it's -4, but distances are positive. What's my y coordinate? Well, we go down 2. What do I have? I have a triangle, right? That I can figure out what's the distance formula between 0, 0 and -4, -2. So you can use distance formula or Pythagorean theorem. They're the same thing, and you get the same answer, which is √20. Hit your calculator, or that's 2√5. Hit your calculator, double that, and you would see that the answer is going to be, I'm running slow on processor power here, people. The answer is going to be C, 8.94. Oh, geez. Oh, geez. Failure here. Oh, anyways, this answer is C, 8.94. Oh. Don't give up. Don't ever give up.